Hey everyone, my name's Brian, and I'm excited to share some React DevTools updates with you. One of the themes of the conference so far has been setting the right foundation for the future of React, and we believe that DevTools is an important part of this foundation. Earlier this year, I joined Jason Bonta, Juan Tejada, and Luna Ruan to form a new React developer tooling team. Our charter is to create a great React developer experience. DevTools are a key part of this experience. There are tools to make you more productive when writing new components or exploring unfamiliar projects. There are tools for debugging problems with suspense or error boundaries. And there are profiling tools to identify performance problems and in some cases, even suggest how to fix them. React DevTools can be used in the browser as an extension, or as a standalone app for React Native developers. It can even be embedded into tools like CodeSandbox and Replay.io. Before we go any farther, let's take a quick look at how DevTools work for anyone who's curious. React DevTools has two pieces. One part is the UI you interact with, and the other runs in the same memory space as React. For the browser extension, it runs in the page along with your JavaScript. For React Native, it's shipped on the device in the React Native runtime. React connects to DevTools during startup and sends it messages to let it know when things change. Then DevTools figures out which components were added or removed during the update. Here's an example. This is a to-do list with a single to-do item. If we add a second item to the list, React will let DevTools know that there's been an update, and DevTools will find the new item and show it also. To be clear, you don't need to know how React and DevTools work together to use either one, but I think it's interesting. Okay, let's talk about some new DevTools features. The React team introduced hooks at ReactConf 2018 as a way to add state and other types of interactivity to function components. DevTools supported hooks from the start, allowing developers to inspect and edit hook values. But people told us that hooks were difficult to debug because they didn't have names. For example, consider this component that uses the state hook. Unless I look at the component's source code, I don't know what these state variables are being used for. The way we name variables is an important part of how readable and maintainable our code is, and hooks are no different. So why didn't DevTools show hook names? When people refer to the name of a hook, they're typically talking about the variable the hook's return value gets assigned to. Unlike props, which is a keyed object that DevTools can iterate over, there's no way for DevTools to read the name of an arbitrary variable inside of a component. Or is there? DevTools can download the component's compiled source, search for a source map, use the source map to extract the original code, and convert it into a syntax tree, which is a tree structure describing the statements and expressions in the original source code. Then it can extract the name of the variable we care about. Here's a quick demo of DevTools doing exactly that for the component we just looked at. Support for hook names launched earlier this year, but it's a feature we're still actively developing. For instance, we don't currently support all source map types. For example, Webpack's default cheap dev source maps won't work with this feature. We also have some ideas for ways we might speed up the downloading and parsing of source maps. And we hope to eventually use hook names in the profiler when showing why a component re-rendered. As always, we'll keep you informed of our progress here. But before we move on, I'd like to take a minute to thank the community contributors that helped make this feature possible. I mentioned earlier that DevTools has a profiler to highlight performance problems. This tool has been around for a while, but let's take a quick look at it for anyone who may be unfamiliar. First, let's record a small profile. This is done by clicking the record button to start profiling, using your app a bit, and then clicking the same button again to stop profiling. The profiler records information about how fast components render each time React updates. Those updates are displayed as bars at the top of the profiler, and you can view one by clicking on it. The taller the bar is, the longer the update took. If you'd like, you can configure the profiler to hide the fastest updates so that you can focus on the ones that took the longest. The profiler also shows informational tooltips about why each component rendered during an update. This can be useful if you see a component re-rendering when you don't expect it to. Eliminating unnecessary renders can be one way to speed up a slow application. Profiles can also be exported so that you can view them later or share them with others. You can find a lot more information about this profiler on the React website if you're interested. The profiling tool we just looked at has been around for a while. It's useful, but it has some limitations that we think are important to address in order to set developers up for success with React 18. For example, we've noticed that the way the profiler groups updates by React commit can be a bit too abstract when you're trying to identify the cause of a performance problem. Thinking about React 18 features specifically, the profiler doesn't tell us much about what goes on when React yields so that the browser can paint or run other JavaScript. And it doesn't give us a sense of how long our application spends loading data or how React prioritizes what it works on. To address these issues, we added a new tool to React DevTools that we're calling the timeline. It looks more like a traditional browser performance tool in that it shows data along a timeline rather than grouping it by commit. But unlike browser performance tools, the Timeline tab provides React-specific insights and suggestions. Let's dig into how this tool works with some examples. We'll start by taking a look at how the timeline shows updates. Here's a component that uses a state hook to store a count variable. The count is updated when a button is clicked. If we were to record a short profile of this app, it might look something like this. In a click event handler, our component schedules a state update with React. This causes the app component to re-render, which updates the screen to change the count from 0 to 1. This example is basic, but I hope it demonstrates how the timeline can be used to trace cause and effect in a React app. Let's take a look at another example. Here we have an app that filters a list of names using the current value of a text input. Both the input and the filtered list are controlled by a single state variable named text. For this example, I recorded a profile with CPU throttling enabled so that the filtered list component runs very slowly. When I type into the text input, our app schedules a single, high-priority update. As a result, both the input field and the list of filtered names get updated at the same time. Because of this, the overall update takes long enough that the input feels laggy, so the timeline tool warns us to separate these updates. To do this, let's use one of the new hooks introduced in React 18, deferred value. This hook accepts a value, like text in this case, and returns a deferred version of that value that may lag behind a little. Let's take a look at how it works. We'll leave our input bound to text so that React can update the value it displays at a high priority. But we'll update the filtered list component to use a deferred value. This change will let React do the more expensive job of filtering the list at a lower priority. Here's another profile I recorded of this updated version of our app. Now when we type into the filter input, React runs a high priority update so that the filter text gets updated. Once that update is done, React runs a lower priority update to filter the list of names. Separating these updates enables the text input to feel responsive and keeps the overall UI updating fast enough to feel smooth. Let's talk about another upcoming React API called Suspense. Suspense is a way for components to tell React that they need to wait for something before they can finish rendering. We'll take a look at an app that uses Suspense in the Timeline tool. In this case, we're going to profile the DevTools extension itself. When you select a component for inspection in DevTools, it uses Suspense to wait for the component's state and other information to be fetched. Here's what that looks like in the timeline. When we select a new component in the list, it schedules an update with React. Then, during render, DevTools suspends while it fetches the component's props and state. Looking at the screenshots below, we see the selection change, and a loading fallback is shown on the right-hand side. Then once the data finishes loading, the props and state are shown in its place. Loading hook names is similar. We click a button to tell DevTools to load the hook names. Then it suspends, this time for significantly longer, because loading hook names is a lot more complex. Let's take a quick look at the DevTools UI itself. One of the nice things about Suspense is that while DevTools is waiting for hook names to load, React does a small update to disable the button we clicked, so that the user gets some visual feedback that it's responding to our request. Then once the data has finished loading, React renders again and displays it. Looking back at the timeline, we've seen the same things happening in the screenshots at the bottom. I mentioned earlier that the timeline also shows how non-React JavaScript impacts the performance of an application. Let's take a quick look at a profile of an app that was interrupted by a network request. In this case, when the network request finishes, JavaScript does some expensive JSON parsing. All of this happens outside of the React render cycle, but the timeline view still shows us what's going on. The first thing we notice in this example is that there's a big pause between when React renders initially and when it updates. In fact, there's about 2 seconds between. The new timeline view can help us figure out what's going on between these points, though. Let's expand the flame chart and network panels. Zooming in on the network strip, we can see that we spent some time waiting for a network request, but only a small amount. Looking at the flame chart portion, we can see that here's where the bulk of our time was spent, about 2 seconds worth, in a function named parseItems. Once that function finishes, an update's scheduled with React and our app renders again. As a side note, the timeline de-emphasizes frames that belong to React internals in the flame graph so that your application code stands out. The timeline is an essential part of understanding the performance of React 18 applications, and we have a lot more planned for it over the coming months. Before moving on, I want to take a minute to thank the community contributors who helped make the initial launch possible. I mentioned earlier that the named hooks feature is still a work in progress. Let's talk about a few other things the developer tools team will be working on in the coming months. You may have noticed from this talk that React now has 2 profiling tools, the profiler and the timeline. Both are useful, but they aren't connected. You need to start and stop them separately, and the data they export is in a different format. We have plans to merge these tools and to add support for React Native along the way. Speaking of which, React Native is well positioned to be the default approach for creating 2D VR applications and even some 3D experiences. To support this, we'll need profiling tools for CPU and memory usage, as well as general support for inspecting and debugging VR applications. Server-side rendering is crucial to the success of many websites, and we believe that server-driven UI can be successful on mobile and VR as well. As part of our ongoing investment in this area, the developer tools team will be adding support for debugging and inspecting components rendered on the server, as well as profiling them. We also have some ideas around tools for debugging and visualizing how fast a server-rendered React page becomes interactive on the client. As React grows, so will DevTools. New APIs will be added, new profiling tools will be built, and we'll work to improve the developer experience with surfaces like native and VR. We look forward to working with you all, and we hope you'll continue to share your feedback and ideas with the team. Thanks for listening.